Hello ladies and gentlemen, and welcome to a very different video. Rather than doing a Scratch tutorial, I'm going to be showcasing something that I've always wanted to do in Scratch, and I just finally got around to doing it, which is creating a programming language inside of Scratch. Yes, you heard that correctly, and no, I'm not kidding you. This is actually legitimately Turing-Complete coding language. Now, there's no inputs, so you can't control it with arrow keys. It's just kind of whatever you type in happens. But it's still pretty advanced. So let's start with something basic. How about let's start with something that counts from let's say 0 to 10. How's that sound? Alright, so let's start. First, we're going to have to put a 0 into our register. So the way this works is on this side, this list. This is the code that the program will run once we run the program. And over here, the registers, these are pretty much our variables, or the equivalent of variables in Scratch. So let's start with making a new variable and setting it to 0. So to do that, we use WRT just for fun, because I wanted to do it. Every single command is 3 letters long. And I always do it all caps. You don't have to. I just do it like that because I think it's cool. Anyways, WRT or write. So this command takes 2 operands. What that means is pretty much if you're familiar with Scratch custom blocks. Scratch custom blocks, you can add inputs. This is pretty much how many inputs my commands have. That you can have up to 3. Was it 3 or 4? I can't remember, honestly. But I think it was 3. Yeah, you can have up to 3 inputs. This one only has 2, which are the location. Oops, I pressed space. The location and the number that you want to put in. So first we put the location. So we're going to put it into register number 1. So we type 1 space. And then what number we want to put in, which will be 0. So we type 0. We hit enter. And that gets put into our code. So next, we want to have it count up 10 times. So in order to do that, we need a loop. So here comes the repeat command, REP or repeat space. Then you put how many times you want to repeat. You put 10. Okay. Next, we need to add to the register. So we use the add command, ADD. So this one is a bit more complicated. This one takes 3 inputs. So again, location, where we want to put the result, 1, space, the first number that we want to add, which is 1, because we want to add 1 to it, and then our second number. Now keep in mind, we want to get whatever value is already in the first register. So in my programming language, in order to do that, you start with a 0, and then whatever register you want. So we want to access register 1, so we put 0, 1. And then we need to end the loop, so we put end, and then we need to end the program, which also uses end. So pretty much here, this actually, let me check. Am I capturing mouse? I'm not capturing mouse, I don't think. Okay, well, I can still highlight anyways, that's fine. Sorry for showing OBS everyone, it doesn't matter. Anyways, this repeat loop is this pretty much puts us into a loop. And then this end command takes us out of the loop, and then this second end command isn't connected to a loop, therefore it just ends the program. Anyways, now we can run it, and in order to run, I have to introduce you to the idea in my language of E commands, or I guess external commands, as I like to call them, which are pretty much commands that they don't write into the code, they don't affect anything in the code, they affect the actual program itself. So the most important one is erun, which runs the program. However, we're actually going to use a different one, which is espeed. And now it says new time between ticks. So this is how fast is our program going to run. So let's put 1 second in between each command. And now we use erun to run the program, and we'll see what happens. Hide list. Oh yeah, sorry, I forgot. This program is also able to use the pen extension to draw onto the background, but sometimes you don't want to make a program that is graphical. You just want one to work with the registers and look at the registers. So that's why it asks you Y or N. Do you want to hide the list? So we'll put N. no, so that we can still see the number. So let's look. First the 0 gets put in, then we add 1, then we add 1 again, and we add 1 again. You see our loop is working correctly. So we'll just wait here a little bit until it reaches 10. It has reached 10, and now the program has stopped. Isn't this just the coolest thing ever? I know it doesn't look like much right now because I wrote a very simple program, but you can write a ton of stuff. Oh, by the way, there I just used the eClear command. Let me type some stuff back in so that you can see it. Okay, so eClear, when you type it in, it says clear code C or registers R. Here, if you type just the letter C, it'll just clear the code. If you type just the letter R, it'll just clear the registers. This is kind of redundant now. This was in an earlier version of the program. Registers wouldn't reset every time, so you had to reset it by this command, but nowadays it's kind of redundant. So if you don't type any letters, you don't type C, you don't type R, you just hit enter, it'll clear everything, both registers and code. Anyways, let's write something else. So oh, this is one I like. Let's do another command that counts. This time let's do 50, but rather than using a loop, we're going to use an if statement. So here's how this is going to work. We're going to do write 1 0 again, write 0 to register 1. Then we're going to straight away add 1 0 1 1. So we're adding whatever is in register 1, we're adding 1 to it, and then we're writing it back. Oh, sorry, I forgot, I have to highlight. We're taking whatever is in register 1, we're adding 1, and then we're putting it back into register 1. Alright, next, after the add, we need the if statement. So first we actually need to get our number. So let's do, I believe it was GRT, is to check if it's greater than. So we're going to do greater. We're going to do is the value. Oh yeah, we have to. The result is going to get written into 2. Then we're going to do. Well, oh yeah, okay. The result is going to get written into 2. Then is whatever is in register 1 greater than 49, because 50 is 1 greater than 49, so it'll work like that. So hopefully that works. I can't remember if GRT is the correct command, but then we have to invert it, because if it isn't, then we want to repeat it. So we're going to do not, write it into 2, and then we're going to take 0 2. So the not command, it'll take whatever's in register 2 and then invert it and then write it back into register 2. So next we're going to do, finally use the if statement. So we're going to do if 0 2, we're going to JMP. Oh, wait a minute. Okay, I'm sorry. I really didn't want to show the code here, but I kind of have to, because I genuinely forgot the commands. So let me just check. Yeah, there's a ton of commands that I'm not going to show because they're okay. Yeah, again, as I said, I made every single command 3 letters, including if. If just has two F's. But anyways, and if you make a mistake and you don't want to reset everything, you can just put E back, and it'll remove the latest line of the code. So now, if 0 2, we're going to do JMP, which I'll explain in a little bit, and then we're going to do 2 end, so that it closes the if statement, and then end again. So what does JMP do, or jump? Pretty much whenever this gets activated, it will immediately jump to the second line, or whatever line we fed into the command. So if we put JMP 10, it'll jump to line 10, and you get the idea. Now let's see if this runs, because I haven't programmed in this in quite a bit, so let's see if this actually works. I'm turning the speed down, or I guess up, so it runs faster. Let's see if this works. Oh yeah, end. Oh, look at that, it's working. It's writing the results into 2, and then checking, and then it keeps repeating. Actually, I'm going to restart this and turn the speed up again. Let's do 0.05. Now run. N. There we go. So now, as you can see, it's working exactly as intended. And after this command, or after this code demonstration, we'll move on to graphical code, or graphics, how to do graphics. But yeah, as you can see, it has just written 50 into this area. Alright, now let's get into the cool stuff. Graphics. So, graphics, I had a really hard time struggling how to figure it out, because, you know, I could have done like a dot command, which just draws a dot on screen, and then have it say like, oh, feed from this register, have it be like an X value, and then a Y value, and like a size or something like that. But I decided that that's kind of odd, so, and it would be like hard to do, you know, you don't want to take out two registers, so I developed an entire format which takes an XY position on screen and turns it into a single number. So, I believe it is the CRD command, coordinate. If you then put where it's going to be written, and then this is where you put the location. I can't, oh god, I have to check the code again. I can't remember if I made it, so that the origin is the top left, or if it was the actual middle. Looks like it's the actual middle. So, yeah, let's do 0, 0. Oh yeah, I forgot. When I was writing 0 to the first register, I actually didn't need to do that. It automatically acts as if every register already has a 0 in it. I was just doing that so it looked neater, and I felt better about myself. Anyways, now we have the coordinate command. This will take the coordinate 0, 0 and write it as a single number into the register. So we'll actually just run this right now just to show it. As you can see, this is my what do I call it? I call it like register RCF. That's what I called it. What was it? Register coordinate format. That's what I call it. I don't know. I didn't have to call it that. I just called that because it felt nerdy and I liked it. But yeah, this pretty much this command takes an X and Y value and formats it to RCF and then puts it into the register. Anyways, let's actually make use of this now. So we do eback, do dot, which is a real command, and then I think, if I remember correctly, you just put in the number and then you do end. That's erun, and we'll actually hide the list this time with Y, and look at that, the tiniest dot right there. Let's do a few more dots. Alright, so we'll do clear. So let's do coordinates 1. We'll do negative 50, 50. Then we'll do coordinates 2, 50, 50. Coordinates 3, 50, negative 50. Coordinate 4, negative 50, negative 50. What next? Oh yeah, I think there's a line command. It's been like a few months. Actually, no, not a few months. It's been like a few weeks since I've used this, okay? So, give me a break if I need to check if the code, make sure I do this right. Yeah, it's, oh no, it's LNE, not LIN. Okay. So, this is a LNE, or line command, which draws a line between 2 points. So, we'll do, the first point is in register 1, and then register 2. Then LNE, register 2, register 3. LNE, register 3, register 4, LNE, register 4, register 1, and then end. And then we'll do erun and see if this works. There it is. It drew a square. That's how you do graphics. Now keep in mind, the program runs really slow. It is super slow. If you have any like real-time stuff where it's on a forever loop, don't do that. It's really not gonna work. It might. It's gonna look super stuttery though, and it will likely not you will not get the desired effect. Anyways, there are tons, and I mean tons of other commands I could show you. There are way too many for me to show all of them. Here's an example. RDX and RDY. RDX and RDY take an RCF value and just get the X and Y value out of it, depending on whether it's RDX or RDY. RDX gets the X value, RDY gets the Y value. So you put RDX 1 and then your value, so it would be the value in register 1, and then that would take the X coordinate of whatever this number is. What other commands are there? There's, I showed greater before, but there's also lesser, LSR, which is another Boolean true or false command that checks if a number is lower than another number. There's also EQL, which is equal. What else is there? There's oh right, I think I was, again, as of recording this video, this project is not finished yet. It is not out yet, but I think I was working on an actual way to get a get you to like be able to interact with it, like without like with arrow presses and stuff. I don't know. Pretty much any function you know of in Scratch, absolute, modulo, cosine, sine, I think tangent as well. Maybe not tangent yet. I need to add those. But yeah, cosine, sine, mod, letter of, join, all that stuff. Pretty much everything in the operations thing is in this program. Random, greater than, has. Has is the contain command. So if does this contain this, or with 2 R's because 3 letters, and there's a lot of stuff. Oh yeah, there's also if-else statements. So that's cool. Alright, now as a final show of this, the power of this thing, I'm gonna make a guessing machine. What this does is it pretty much plays hot or cold with you. Or no, hot or cold, no, what's the other one? That's like greater or lower. I don't know, pretty much you give it a number, and then it you give it a number, and then it guesses or figures out what number it is in the most efficient way possible. Because when you think about that, you might think, oh, just choose a random number over and over again until it gets the right number. But if it's like a number between 1 and 50,000, that's going to take a really long time. In fact, I'm pretty sure statistically, it's going to take infinite amount of time. Actually, probably not infinite amount of time, but a really, really, really long time. So, instead what this does is pretty much when it guesses a number, and then it asks, is this number lower or higher than your number? And it will then, depending on your answer, adjust its guesses, and yeah, we'll figure it out. So, I'm going to write it, and I'm going to explain it as I go on, but if you want, you can skip ahead and see if you can figure out how the program works on your own by just reading it, and see if you can fine-tune your skills on learning this thing. Anyways, yeah, let's do 0 to 1 million. Yep, that's 1 million. Okay. So, then we are going to give it, finally, our number. So, this right 1 is going to be the lowest search. This right 2 is going to be the biggest search. And then right 3, or I guess, register 1, lowest search. Register 2, biggest search. Register 3, the actual number. I get that it can just get whatever number it wants, but whatever. Okay, so let's do 2,894. That'll work. Now, let's do, okay, how do I do this? So, I already programmed this before, I just have to remember. So, we're gonna do, first of all, it's gonna make a random number, which is RND, random command. It's gonna write it into register 4, and it has to be in between register 1 and register 2. Then, if... actually, no, I forgot. I have to do the checks first. Okay, lesser. Oops, press the wrong key. Okay, so is this number less than the greatest search? In which, actually no, is this number, how do I, okay, I'm trying to remember how I do this. Okay. Is this number less than, okay, is my guess less than my true number? If it is, then we are going to make our lowest search what we guessed, and then we are going to jump back to the to our guessing thing. Then we're going to end that if statement. Then we're going to do if it is, oh no, sorry, GRT is it greater than our low search. So again, we'll write that into 5 because we don't need the lesser value if it doesn't work. Is 04 greater than the correct number? If so, then we are going to write it into the grade number, and then we're going to jump back to 4 and that, and then end that. Okay, now I'm going to test it. I'm not 100% sure if it'll work, but we'll see. Let me turn the speed down just a touch. Alright, now you run. Let's see if this works. Alright, don't hide lists. Look at that. Look at that. Did you all see that? That was awesome. It worked. It guessed the number. So, in case you skipped ahead to this point that I probably put a timestamp to, and you want to figure out how the code works, I'll let you look at this code, and I'll scroll down so you can see the rest of it. And yeah. Alright, so now I'm going to explain the code more thoroughly. We start by writing the 3 numbers that we need. We write, to register 1, we write our lowest possible guess, which in this case is 0, our highest possible guess, which in this case is 1,000,000, and then our true number that we want to find, which is 2,894 in this case. Then, into register 4, we pick a random number between whatever is in register 1 and whatever is in register 2. So, anything between 0 and then 1,000,000. And then we check, is that lower than our true number that we want to find? If it is, then that means that this has to become our new lowest number, because that if we go lower, then we are going to get a wrong answer. We know for certain. So we write this back into our lowest possible guess, and then we jump back to our random search. If that if statement fails, it instead checks if it's greater, and if it is greater than our true number, then we write that into our highest possible guess. And then we jump back to our guess, and then if both of those fail, the entire program stops, meaning that we found our real number. So, next, I don't know why I said next, pretty much what this does in layman's terms, or explaining it like a human, it'd be like you pick a number between 1 and 1,000,000, and then someone tells you a number, say 8,000, and then you tell them, no, my number is lower than 8,000. They now know, do not pick a number higher than 8,000 because it's going to be wrong. So they might pick 4,000. Nope, it's still lower, so they have to search lower than 4,000. Then they do 3,000, and then they're like, and then you say, no, it's still lower. So they know not to search higher than 3,000. So then they say 2,000. Then you say, no, it's higher. So now they know it's in between 2,000 and 3,000. So they say 2,000, 800, and you say no, it's higher. So now they know it's 2,800, and it's between 2,800 and 3,000. So then they pick a bunch of numbers, and eventually they get 2,894 through pure process of elimination, and you telling them whether they're higher or lower. Final thing, let me go through some of the other E commands, external commands. So we have insert, which inserts a specific instruction at a specific place in the list. Let's say we want to, I don't know, let's insert where, let's insert it in the first place, and we'll just put, hi, this was inserted. It just got inserted there. And also we can do delete, which is similar to back, but it's a specific line that gets deleted rather than the most recent one. And then there's also replace, which replaces a very specific line. So let's do replace line 3, and instead of making our real number 2,894, let's do write, let's do 8, that number 6 3. Yeah, that'll work. And see, it got immediately replaced. Let's actually run it and see if I can guess this number. There it is. It got it. But yeah, that is my programming language, which I just call Kirby code or K code, just because I'm not at all good with names. But yeah, I'll probably have a manual in the description that I'll write later. And this was just a showcase. Maybe it'll be a devlog, and this won't be out by the time the video comes out. I really don't know. I just kind of filmed this because I really, really wanted to share this with the world. So, yeah, like and subscribe if you want to see more Scratch stuff, maybe more game development stuff, maybe some Game Builder Garage stuff, just stuff. And like it and share it with people. And all the things YouTubers say because they need money. I don't need money. I am not monetized. You do what you want, but if you like it, then like it. Goodbye.